Researchers conducted experiments with trees. Listed below are weights in kilograms of trees given no fertilizer and trees treated with fertilizer and irrigation. We want to find the range, variance, and standard deviation for each of the two samples and then compare the two sets of results. Does there appear to be a difference between the two standard deviations? Well, first we need to understand that there are two samples here. And these are samples, not populations. So we're going to start with the first one, no treatment. And for this one, what we're going to be looking at is 5 data values. And we'll go ahead and we're going to write those data values down in a table. And we'll start with this as no treatment. This is going to be my X, and then I'm going to write down my 5 values, and I'm going to list them in sorted order from least to greatest. And then, once I do that, I'm going to go ahead and sum my column. By doing that, I can then use that information to obtain the mean for the first sample set. So we'll do sigma x, which in this case will add to 1.33. Then we're going to go ahead and find the mean. The mean for this is going to be x bar, and that will be equal to sigma x divided by n. And this will be little n, which is going to be my sample size, and in this particular case little n is going to be equal to 5. So this will be equal to 1.33 divided by 5, and when I divide by 5, the 1.33 is going to yield the following value, and it's going to be an approximate, and that's going to be 0.266. Now once I've done that, I'm going to create a new column, and this new column is going to be x minus x bar, and that means that I'm going to take this x value and I'm going to subtract the mean from it. So we have 0.15 minus 0.266, which will equal negative 0.116. And I'm going to do that for the remaining 4. Now once I complete that, I'm going to create a new column, and this new column is going to be x minus x bar quantity squared, which means that I want to take each one of these values and I'm going to go ahead and square them. And when I square this one, I'll get 0.013456, and I'm going to go ahead and do that for the remaining 4. Okay, we've completed this section, and now we're going to sum this column also, and this is simply going to be entitled as sigma x minus x bar quantity squared. And when we add all of these 5 values, we end up with the following. Now you'll notice that I am not rounding at all. I will not round until the very last step, and this is where a lot of students have problems, is they end up rounding before they get to the end step, and then they will end up with a different answer than what is required. Now we're looking for variance, and we're looking for standard deviation. So first off, we're looking for variance, and remember that variance is given by lowercase sigma quantity squared, and this will be equal to the following formula. Now you have to make sure that you use the correct formula, because there are 2 formulas. This is for a sample. So variance for a sample, and it's simply going to be the summation of x minus x bar quantity squared all over little n. And remember that little n is going to be the number of data values in the set, or the data set. And so when I go ahead and I calculate this, I end up with 0.02932 and I'm going to divide that by, oh, and I'm sorry, this should be little n minus 1. And I'm going to divide that by 5 minus 1, which is going to give me the following. And this is equal to 0.00733. Now I also want to find the standard deviation, which is equal to sigma, lowercase sigma, which is the square root of the variance, sigma squared, which means that we're looking at the square root of 0.00733. We type that into the calculator and we will get the following answer. And this will be equal to the following, which will be 0.0856154, so on. And we're going to round to 3 decimal places, which will be approximately equal to 0.086. And we're going to do the same thing for the next part of the problem so that we can compare the standard deviations. Now, one of the things that I want to show you is how easy it is to use StatCrunch for this. We're going to go ahead and open the problem up so that we can see it. And here's the problem. And StatCrunch is right here. But there's also an icon that allows me to copy the table. If I left click that, I get a pop-up window. One of the menu choices is open in StatCrunch, and I will left click that, and that will bring up StatCrunch for me. Okay, we'll left click open in StatCrunch. And it brings up StatCrunch. And notice that both data tables or data sets are now contained in StatCrunch. I want to do the sample variance. I want to do the standard deviation. I also need to find the range. So this is how I'm going to do this. I'm going to go ahead and left click stat, and then I'm going to highlight summary stats and then highlight columns and left click columns. I'm then going to left click no treatment, hold down the control key and press or left click fertilizer and migration. Under statistics down here, I'm going to go ahead and left click N because that tells me how big my sample size is. I also note that I need the range, so I will left click range, but I will also hold down the control key at the same moment. You'll notice that both of these now appear here. I'm still looking for the variance and the standard deviation. There are going to be two options in StatCrunch. There's going to be variance like this, and there's going to be standard deviation like that. And that is going to be for a sample. If perchance you happen to scroll down, you will see unadjusted variance and unadjusted standard deviation. Those are for a population, and it does not subtract 1 from the number of data values in the denominator of that radical that we were using. So let's get rid of this and this, and we'll go back up and we'll highlight variance and standard deviation. Notice that I have both data sets lined up here, and now I will left click compute, and this gives me a new table. And you can see this table right here. It's going to have column, no treatment, fertilizer, and irrigation. It's going to tell me how many values are used in both. Then it's going to tell me what the range is for both of them, the variance for both of them, and then the standard deviation for both of them. And then you should be able to just go ahead and continue on your merry way with this. So we'll go ahead and we'll look at this, and we note that this answer is 0.086, and that's what we get over here. So if I were to copy this, so now I can show you that when we look at both tables, or I should say the outcomes from both tables, we'll see the range, the variance, and the standard deviation for both no treatment and fertilizer and irrigation. And these values are what will be entered into the online homework.